Take the word book. In read a book, it's a noun. In book a flight, it's a verb. Same spelling, completely different grammatical role, and the only thing that tells them apart is the words around it. Part of speech tagging is the foundational task of labeling every word in a sentence with its grammatical category, whether that's a noun, a verb, an adjective, or something finer. It sounds simple until ambiguity shows up. Let's walk through how a tagger actually handles it. Here's the core mistake to avoid, laid out as a contrast. Treating each word in isolation looks tempting, but it falls apart fast. The word well can be a noun, an adverb, an adjective, even an interjection. Look it up alone, and you can't possibly know which one applies, because the answer was never in the word itself. It was always sitting in the words around it, waiting to be read. POS tagging uses context instead. It reads the surrounding words to decide each word's grammatical category. So book beside a flight becomes a verb, while book beside read becomes a noun. Context is what turns an impossible guess into a confident label. And it's exactly why the task is treated as a sequence problem rather than a word-by-word lookup. Now, follow the actual steps a tagger runs as it processes one sentence. It starts by reading the words in order, left to right. Word order matters here because a tag depends heavily on what came before and after, so the tagger treats the sentence as a sequence rather than a loose pile of words. That ordering is the whole reason context can do its job at all. Then, for each word, it considers every possible tag that word could take. A word like well opens up several candidates at once, and the tagger holds all of them as live options rather than committing too early to any single one, since an early wrong guess would poison the words that come after. Next, context does the deciding. Using the surrounding words, the tagger narrows those candidates down to the reading that actually fits the sentence. This is the disambiguation step, and it's where most of the real difficulty lies because so many everyday words carry more than one grammatical role. Finally, it outputs the most likely tag sequence for the whole sentence. Classic taggers used hidden Markov models and later conditional random fields, treating this as a sequence labeling problem and running the Viterbi algorithm to pick the best sequence overall, not just each word alone. So, 3 ideas really define this task, and they explain why it endures. First, the goal is simply to label each word's grammatical category. Noun, verb, adjective, adverb, pronoun, preposition, and often a fine-grained set like the Penn Tree Bank's dozens of tags, giving far more detail than the basic categories alone. Second, context resolves the same word's many roles. Because a single word can play several parts of speech, the tagger must read neighbors to choose, which is exactly why modern systems use neural networks trained on plenty of sentences. Third, tags are a building block for everything above them. They feed parsing, named entity recognition, and information extraction, and help distinguish word senses. It's one of the oldest and most studied tasks in the whole field, with the best taggers reaching around 97% accuracy, which is why it quietly sits under so many bigger systems. All right, 4 takeaways to carry with you. POS tagging labels every word with its grammatical category, from broad classes to fine-grained tag sets like the Penn Tree Bank. The same word can be several parts of speech, like book, well, or run, so a tagger must read the surrounding context to decide which one fits. Classic taggers used hidden Markov models and conditional random fields with Viterbi. Modern ones use neural networks and reach around 97%. These tags feed parsing, entity recognition, and information extraction, making tagging a quiet foundation the rest of NLP is built on top of. For more concepts unpacked in plain language, just like this one, Standarity.com is where to keep going.